All right, this is a few harder examples, and do this really to illustrate the point of how good this does at balancing chemical equations. And all these are difficult. They get harder as we go from A to B to C. And so here, this has three elements. This has three elements. This has two. This has two. So it's going to be one of these, and they both have three types of elements, and they both have 6 atoms in them. So when we run into that situation, then it doesn't really matter. So I'm just going to pick the first one. So now I've staked my claim to 1 sodium. So 1 sodium there also. I've staked a claim to 4 hydrogens, and I have 6 here. So I'm going to need to do 4 over 6 in order to get 4 out of that. 4 times 6 is 24. 24 divided by 6 gives me the 4 that I need. And then finally, I'm going to balance these fluorines. So 3 fluorines, and this has 4 fluorines. So I am going to do 4 over 3. 4 times 3 is 12. 12 divided by 3 gives me the 4 that I need. Now we will want to go about clearing the fractions that we have in there. And so 4 over 6 will simplify to 2 over 3. Okay, and 12 divided by 3 is still 4, so I'm going to do that as a little bit simpler fraction. And now I can just multiply everything times, and I'll call this my 5th step here, times 3 in my 6th step to try to clear all of that out. So 3 NaBH4 plus 4 BF3s goes to 2 B2H6 plus 3 NaB, I'll run out of paper, F3, oh, 4. Okay, so now let's do that process and verify whether it's balanced or not. So there's 3 sodiums and 3 sodiums, 3 borons. There's 3 borons and there's 4 more, so there's 7 boron atoms. There's 4 borons and then there's 3 more, so 7 boron atoms. All right, I did boron. Now I'm finally, now I'm going to do hydrogen. 3 times 4 is 12 hydrogen. 3 times 4 is 12. 12 hydrogen. 2 times 6 is 12 hydrogen. And then at last I'm left with fluorine. 4 times 3 is 12 fluorines. 3 times 4 is 12 fluorines. So perfectly balanced. All right, going to get a little bit harder. The easy part about this one is, so this is definitely the most complicated species. It has, 10 atoms in it, and it has 3 types of atoms, so I don't have a problem identifying the most complex species. There it is. Once I've staked a claim to 3 sodiums, I can go ahead and say that I have 3 sodiums there to try to get that to balance. I've said 1 aluminum, so I'm going to confirm that and say I have 1 aluminum there. Fluorines, 6 fluorines, so I need 6 fluorines from there. And now I don't have anything else to balance against this, so I'm going to balance against what I have over here. So I have committed to 3 oxygens. So let's see what that does for us. 3 oxygens right there. And that was step 5. So 6 hydrogens, and I have here I have let's do this. Lost some oxygen, sorry. So we got 3 oxygens here. Those were the ones that I lost. We got 3 oxygens here. So I need to have 6 oxygens there. There we go. That's looking better. So 6 oxygens means 12 hydrogens, and we've got 6 hydrogens here. we've got 3 hydrogens here, and we've got 3 hydrogens that are there. So now this is actually perfectly balanced. Let's confirm that it is. So 1 aluminum and then 1 aluminum. We have, as I had to refigure here, 3 oxygens and 3 more, so 6 oxygens. And I've got 6 oxygens. I'll put oxy there so it doesn't look like a 0. I've got 3 and 3 more and 6, so 3 and 3 and 6, I have 12 hydrogens. And 12 hydrogens. I have 3 sodiums. And I have 3 sodiums. And I have 6 fluorines, and I've got 6 fluorines. All right, last one. And this last one is a bear. Okay, so we have to figure out what's the most complicated species, and I think this would be it. 7 total atoms, 2 types of atoms, 7 total. So I'm going to put a 1 there, and I did that as step 1. Iron I'm going to leave for later because there's iron in 3 places, here, here, and here. Oxygen, though, is only in 2 places. I'm going to go ahead and try to balance those oxygen atoms. So 4, and that puts me a 2 there. So now I've committed to 8 hydrogens, and so hydrogen's just in one other place, so 8 hydrogens. That's my 3rd step. And now is where it becomes complicated. So we have committed to 8 chlorines. Both of these guys have chlorine, so chlorine is in 3 places, and iron is in 3 places. And so we actually have to go back to that old school method to figure part of this out. So we've committed on this side to 3 irons and 4 oxygens and 8 hydrogens and 8 chlorides. Over here thus far, we haven't committed to irons yet because the iron's still in play. We have committed to 4 oxygens. We have committed to 8 hydrogens. And chlorines, we haven't put any numbers there. So chlorine is also still in play. Well, we've got an interesting situation here. So we either can have 1 and 2, so 1 of iron 2 chloride and 2 of iron 3 chloride, or 2 and 1. Ooh, okay, so let's see how those 2 scenarios would play out. Let's see, we'll do 1 and 2, and here we'll do 2 of those and 1 of those. This one is a beast, so if you're confused, it's you're in good company. So 1 iron and 2 iron, so this would give me 3 total irons, as it has to, and then 2 plus 6, so 2 chlorides from here and 6 chlorides from here, so it would give me 8 chlorides. This one's looking like the better scenario. Whereas if I put a 2 here and a 1 here, that also gives me 3 iron, so that part doesn't give me any information. But 2 times 2 is 4, and then if I had a 1 here, this would be 3, that would give me 7. So the correct one is 1 and 2 in those positions. And then that would be properly balanced. Probably the hardest one that you'll ever see.